we talked in the last lesson about finding the greatest common factor of these polynomials, right, with all these variables in there. And I started to show you guys a little bit about how to factor that. So you find the greatest common factor and you extract it out from your polynomials. That's all this lesson is going to be, is diving a little bit more into that. So if you're following along at home, page 35, example number 1 is on page 141, and it looks something like this. We have 2ax plus 2ac. So we look at these two chunks. I got a chunk here and a chunk here, right? What do I have in common with those? Well, first with the variable, or with the numbers, it's 2, right? And then I have an a here and an a here that I can get rid of. Now, I have one x here and one c here, but they don't have that in common in those chunks. So what do I need to multiply 2a by to get 2ax? Got to throw an x in there, right? Plus, what do I need to multiply 2a by to get 2ac? C. All right, so that's all there is to this, is you find that greatest common factor and then you figure out what you need to multiply it by. So it's like that reverse distribution, if you will. Let's look at example number 2. And guys, if you're in my class, you need to be writing these down because this is how I want to see your work. Always write the problem down. X squared m2 plus a2x m3 minus a4x3 m2. All right, we've got 3 chunks here. Again, chunks are broken up by addition and subtraction, right? All of them have a, x, and m, but it's how many that they have. Let's start with our a's. There's 3, 2, and 4. The most we have are 2, so I can only take out 2. X's, we have x2, x to the 1. Remember, it's not x to the 3 just because there's a 3 over there. It's x to the 1 and x to the 3. The most I can take out is 1x. M2, M3, M2. The most I can take out then are 2 m's. All right, so now we got to figure out, what do I need to multiply a squared by to get a to the 3rd? Just 1. Guys, if this is at all confusing, go back and watch the other video too, just to get some refresher on it. What do I need to multiply x by to get x squared? Just 1x. What do I need to multiply m by to get m squared? Just 1, so it's already there. We're good. Just the number 1, not like m to the 1, if that makes sense. All right, a squared, what do I need to multiply that by to get a squared? Just a 1. A x to the 1, what do I need to multiply that by? No, we got that. M2, I need to multiply that by an m. Now guys, if that had been m2 and this had been an m2 here, we would have at least had to put a placeholder, and that would be multiplied by the number 1. So you got to think about those placeholders. Minus a squared needs to be multiplied by a squared to give me a to the 4th. X to the 1 needs to be multiplied by x squared to give me x to the 3rd. M squared needs to be multiplied by 1 to give me m squared, right? So, and since I've already got a placeholder there, we're good. And when I say 1, it's because all these guys start with 1, right? But you don't always show it, right? We don't like to show that in our math. We're lazy mathematicians. We don't like to write 1 unless we absolutely have to. So that would be our answer for that, okay? That was example number 2. Let's look at example number 3. We have 4a to the 3rd, b to the 4th, z to the 3rd, plus 2a squared, b, z to the 4th. All right, let's extract out what we can. We've got 4 and 2, which I know the greatest common factor is 2. A3, A2, the most I can take out are 2 a's. B4, B1, the most I can take out is 1b. Z3, Z4, the most I can take out are 3 z's. Now, what do I need to multiply 2 by to get 4? 2. A squared times a to the 1 will give me a to the 3rd. B to the, and that's to the 1 power, right? So if it helps, just write it in there. B to the 1 times b to the 3rd will give me b to the 4th in this chunk. Z3, I don't need to put any z's there. Plus, what do I need to multiply 2 by to get 2? Just 1, right? A squared times a squared, b1, nope. Z to the 3rd, need to multiply that by z to the 1 in order to get z to the 4th. So normally I don't write this 1, right? We just get rid of that. It would just be z to the 1 power, right? And so that's what I'm saying about it being needing to be a placeholder. All right, that was example 3. Let's talk about example 4. Yes, this is the one I wanted to do. We're actually going to jump down to example 5, but example 5 here. We've got 3m to the 3rd x y squared plus m squared y. Again, we have 2 chunks here. Bam, bam. What do they have in common? Well, the first one, we don't have a 3 because this is a 1, so I can't take a 3 out. M squared, m to the third, m squared. The biggest we can take is an m squared. X, I can't take it out because there's no x's over here. Y squared, y to the 1, the most I can take out is y to the 1. Okay, so what do I need to multiply all this garbage by to get all this garbage? Well, let's deal with the numbers first. I need to multiply it by 3. Then m squared times m will give me m to the third. There's no x, so I gotta make sure there's an x here. Y times y will give me y squared. Plus, now m squared y, I have to put a placeholder here for 1. If I didn't, if it just looked like this, then when I go to do distribution power, I would only have 1 chunk, right? So I've got to be able to distribute it to another one. So that is a big trick that I see lots of kids get confused on, and that's where they lose track of it. So that is example 5. Now, how does this all apply to canceling? The second part of this lesson is all about canceling. So example number 6 is going to look like this. We have, we'll just start right off the bat, like this, a minus 3 over 4. So guys, if we multiply, if we have something on top that we're multiplying by and something on the bottom, we can cancel these out just like that. And so this would be simplified as a minus 3, a minus 3. Same with this next one, 3x minus 2 over x minus 2. Now, what I cannot do here, I cannot just do like this. It has to be a whole chunk that we're multiplying by. If there's any addition, subtraction, we won't be able to do that. But take a look here. If I throw some parentheses around this, I can get rid of this whole chunk and this whole chunk, which means it reduces down to 3, okay? So let's see about practicing some of these. So example 7, we have 3p plus 3 over 3. We need to simplify this guy down. You guys, we have to factor out that polynomial, in this case binomial, upstairs before we do this. You cannot do this and get 3p equals 3p. Absolutely not. Does not work that way. It goes like this, 3p plus 3 over 3. First thing we have to do is factor out. Upstairs, we can factor out a 3. What do I need to multiply 3 by to get 3p? P. What do I need to multiply 3 by to get 3? 1. Okay? Over 3. Now I'm in a position to be able to get rid of those. Do you notice the big difference here? Up here, when we did it incorrectly, we got 3p. This is what the correct answer should look like. Okay? Let's try example 8. Example 8. All right, again, the incorrect way to do this is to be like, bam, bam. Oh, I've got negative 9x squared. No, you've done it wrong. You've done it wrong. I get so fired up about this that I end up going through like 800 dry erase markers, so bear with me. So let's rewrite that. 3x minus 9x squared over 3x. Upstairs, I can factor out a 3 and an x, right? 3x. What do I need to multiply 3x by to get 3x? 1. Minus, what do I need to multiply 3 by to get 9? 3. What do I need to multiply x by to get x squared? X. On the bottom, I have 3x. Now that I factored it out, now I'm in a position to be like, this guy all eliminates down to 1 plus 3x. 1 plus 3x. So big difference. If you're not factoring that correctly, you're going to get the wrong answer. And I swear I see that happen all the time. All right, guys. So the practice problems are on page. Actually, let's do one more example. Example number 9, right? So we've got 5x minus 25x squared over 5xy. 5xy. All right, guys, so taking a look at this, the top one, I can factor out a 5 and an x, right? If I do that, I get 5x. And what do I need to multiply 5x by to get 5x? 1. Minus, what do I need to multiply 5 by to get 25? 5. What do I need to multiply x by to get x squared? X. Now downstairs, keep in mind, I'm multiplying all those things together. I'm gonna just set that y aside though. So this means the exact same thing as this, right? I just put a little dot in between there. The reason why I did that is now I can get rid of these and these. So what I have left is 1 minus 5x over y. 1 minus 5x over y. Excellent. Excellent. Beautiful. All right, guys, the practice problems are on page 144, halfway down the page. Go ahead and get started on those. Pause the video, do those practice problems, and then come on back to make sure you've done them correctly. All right, pause the video, make sure you've done this correctly. All right, come on back. We've got 5 is going to be our greatest common factor between those two things. And again, we have 2 chunks here, right? There's a chunk, there's a chunk. So we have, these guys are out of order, and this kind of annoys me when it happens, so I end up rewriting it so that it's in order, right? So 3, 5, a, z to the 5th. So we've got this chunk that doesn't change. We have 5. What do I need to multiply 5? Oh, oops, and then we got to deal with the rest of it. I have a2 and a to the 1, so the most I can take out is 1a. Z to the 8th and z to the 5th, the most I can take out is 5 z's. Now, multiply. What do I need to multiply 5 by to get 15? 3. What do I need to multiply a by to get a squared? Just another a. Z to the 5th times z to the 3rd will give me z to the 8th. Minus, what do I need to multiply 5 by to get 35? That would be 7. A, there's already an a there. Z to the 5th, that's already there, so we are good. If you need to double check your work, you can just use that distributive property again and make sure that you did it correctly. All right, so for B, a squared b squared plus 2a to the 3rd b squared plus 2a to the 3rd b to the 6th. We have 3 chunks here. We got 1, 2, 3. They all have 2 in common, so that's easy, right? Let's do 2. How many a's do they have in common? We have a2, a3, a3. The most I can take out are 2 a's. b2, b2, b6. The most I can take out are 2 b's. What do I need to multiply 2a squared b squared to get 2a squared b squared? I gotta multiply by 1. I have to have that placeholder in there. Plus 2a squared b squared. Well, I need another a here, right? 2 times a will give me, or 2a squared times a will give me 2a to the 3rd, and then there's that b squared and the b squared. Plus 2 times 1 will give me 2, right? But I don't write the 1. A times a will give me a to the 3rd, and b to the 4th, b squared times b to the 4th will give me b to the 6th up here. So that should be your problem for B. Now let's talk C. Simplify these guys. We have 4 minus 4x over 4. Upstairs, we're going to factor out a 4, and we get 1 minus x. Because if we, use your distribution property and do it again, we get 4 minus 4x. So that's to double check your work to make sure you did it right. Over 4, these guys cancel out, and what I'm left with is 1 minus x. Let's try D. 7x minus 49x squared over 7x equals. Well, on this top chunk here, I can take out a 7x, right? Because 7 and the 49, right? I would get the 7x and x squared, I can take out an x. Now, what do I need to multiply 7x by to get 7x? Just 1, make sure you have that placeholder. Minus 7 times 7 will give me 49, and x times x, so x times x will give me x squared. On the bottom, I have 7x. This cancels out with this now that I've factored it out, and it reduces down to 1 minus 7x. All right, guys, good work. Let me know if you have any questions. Otherwise, get started on this assignment, and I will see you in class. Thanks, guys.